So we want to graph h of x equals negative 1/3 raised to the x plus 2 power plus 2. So we want to start by identifying what our parent function is. And if you take a look at the base of this function is a 1/3. So our parent function is y equals 1/3 to the x power. Another way of thinking of this would be to think of the negative out in front as changing our graph. The plus 2 up in the exponent with the x, that's going to change our graph. And then the plus 2 that's added on will also change our graph. So essentially we have 3 transformations taking place. And I always recommend that you shift last. So start with the negative that's out in front. Think back to our parabolas, things that we know very well. We know that y equals x squared would be a parabola that opens up. But if I attach a negative out in front, if I multiply it by a -1, now my parabola opens down. So the function of that negative multiplied out in front tells us that the function has been reflected down over the x-axis. And it works the same way even though we have a different parent function. So the first transformation is going to be a reflection over the x-axis. Next we have to deal with the x plus 2 that we have in the exponent. So because that 2 is up with the x, that's going to be a horizontal movement. In this case, that's going to be a horizontal shift to the left 2. Again, these functions shift exactly like all of our other toolbox functions that we graphed earlier in this semester. And then the plus 2 added on to the function is going to move us up 2. So we have 3 transformations total. So you want to begin by graphing the parent function. And if you need to make a table of values to get started for the parent function, you certainly can. You just want to eventually move towards not having to make a table for the parent function. So we're graphing y equals 1/3 to the x power. So if we take 1/3 and we raise that to the -2, that's really going to become 3 to the positive 2 power, and that will result in a y value of 9. Now inputting -1. 1/3 raised to the -1 power turns that into 3 to the first power, which is really just 3. 1/3 to the 0 power is 1. 1/3 to the first is 1/3, and 1/3 to the second would be 1/9. So now let's plot these 5 points, which will give us our parent function. And you'll notice that when we connect these with a nice smooth curve, this function has the 4 commonalities we talked about earlier. The y-intercept is at 1. The domain for the parent function is all reals. The range is from 0 to infinity, and we have a horizontal asymptote of y equals 0. So now we need to do all of our different transformations. So we can start with the reflection, where we're going to reflect down over the x-axis. So every point's going to jump down over the x-axis. So our point that used to be at -2 up 9 is now going to be at -2 down 9. Our point at -1 up 3 is now at -1 down 3. Our y-intercept used to be up at +1, now it's at -1. Notice that the horizontal asymptote does not change, so you can use that as a guide rather than actually plotting some of those fractional points. Now the next 2 steps, shifting left 2 and up 2, you could do them as 2 separate steps, or you could go ahead and just do them together in one step. I recommend that you graph the asymptote first. So think that our asymptote used to be y equals 0. If we move left 2, the asymptote doesn't change. But if we move up 2, the asymptote definitely changes. So our asymptote, which is horizontal, just moves up 2. We have our new asymptote. And then take the 3 points that we have graphed, that were our 3 accurate points, and move them all left 2 and up 2. And you'll get your new points. Left 2 and up 2. Once again, if you graphed your asymptote, then there's really no need to graph the fractional values, because you can just use the asymptote as your guide, and you know that the graph is going to cruise along that asymptote and hug it and get very, very close to it, but not intersect it. And then just label your final answer. On this one, we called it h of x. So label your final graph, h of x, so you know which one is your final answer. In my case here, the green one, that was the graph of y equals negative 1/3 to the x. That was just the reflection. And then what I have in red includes the reflection and the shift left 2 and up 2. So all that's left would be to determine our domain and our range and the equation for our asymptote. So domain, again, the graph is extending to the left and right forever. Our domain is going to be all real numbers. Our range is going to be significantly different, though, because of the reflection. So from lowest to highest, you'll notice the arrow's going down. So our range is going to be from negative infinity, and then it's all the way up to positive 2, where we have our horizontal asymptote, but parenthesis because we're not going to include it. And then the actual equation for our horizontal asymptote is y equals 2. Again, remember, it's important not to just put the number 2, because it really does need to be a horizontal line. So the horizontal line would be y equals 2 for the equation of the horizontal asymptote.